the ICP6 which we are going to create to model a system in which we will use to generate a text. So this is based on RNN and LSTM. So here first we have imported all the imported libraries. Then I have downloaded a text file Sherlock Holmes from the internet, and I've uploaded this one into the Google Colab from here. And here I'm reading the data, and we have total 581880 characters in the text file. So here I am printing the first 250 records or the character from the text file, and then I am taking the unique character from the file. So I am using the set data structure, and it has been sorted. So this is total. I got 98 unique characters into the file. So this is the first 10 characters. So this unique characters will consist of alphabets, digits, and all special characters. That's why we have 98 unifier here. So before processing the before working on the model, we have to process the text. We have to change the text into the numericals so that the model which most which works on the numerical representation of the text file. So here we are creating a two uh, different data structure. First is like character to index, so in which each character will have a index. So and then we are changing index to character using the NP array, and then we are changing the text to the integer. So this is our text as integer, which we have converted text into the integer, and this is the array for the first 10 characters into the text, and it is representing through the uh, integer here. So as a part of prediction task, we have to first I have taken the sequence length as 100, and this is how it will show all characters from the text file. So this is view of the first 10 characters from the text. So the system how it will work, like the first if we'll give the 4 character, if we have a sequence length as a 4 and we are passing, and the text is our like hello, so we'll pass 4 characters, first 4 character HELL, and then target sequence should be ELLO. So the last O will be predicted based on the first 4 character which we have passed. So here we are taking the batch method, which converts these individual character to sequence of the desired size. So this is just a representation how it will work, and we have used the duplicate and shift. We are using the sequence. So for here we have a sequence of length of the sequence is like 100. So here we are splitting the input target, and we are also changing the target text. So target text will be um, one ahead from the input. So this is the data set we have. So we are mapping this one through this function which we have defined here. So it will create the input and target text. So for example, if we'll see here, this is the representation of the first sequence. So this is our input project till the for the, and our target will be, it will remove the P and it will add the last character here. So after the, it will be U. So this is our target and this is our input text. Now here we are creating a batch size. The batch size is 128, and for shuffling the dataset we have taken the buffer size as a 10,000. So here for modeling of the data, we are given the vocab size as the length of the vocab, which is nothing but 98, and we are using the embedding dimension as a 256, and we are creating a RNN model with 1024 units, and we are also adding the down dropout layer, which is have a value of 0.1, so it will drop the 10% of the parameter, 10% of the data. So in our model, first we have an embedding layer for which we have an input as a vocab size. It has a value of 98, and then the embedding dimension, it has a value as a 256, and batch size which we have is here we have defined the batch size, that is a 128. Then we are adding a GRU layer into it with the activation of a tanh, and we have given the kernel initializer and recurrent initializer as Glorut uniform, and then we have a dropout with the dropout rate of 0.1, and at the end we have a dense layer with the vocab size 98. So this is the we have defined as a function like the build model. Here we are calling the build model with the parameters. Then here we are trying the model just to predict for first sequence. So here we can see the length of the input, we have 100, like we have defined the sequence length of the sequence would be 100, and we have a vocab size as a 98 and batch size as a 128. So this is the summary of our model. So we can see 128 is our vocab size, and we have an embedding dimension as a 256. For GRE we has again 128 as a batch size, and 1024 is our number of RNN parameters which we have defined here. So this is our model summary, and here we are just giving the input to see how it's coming up. So next, so before training the model, we have to define the loss function. So here is like it will give the prediction shape and a scalar loss. So here it's saying like the prediction shape we have is 128 as a batch size, 100 is the sequence length, and vocab size is 98, and the scalar loss is 4.584. So before training we have to compile the model. So we have compiled the model which optimizer as ADAM and loss as a loss, which we have defined here, and then we have configured the checkpoints so that checkpoints are saved during the training. So this is the checkpoints we have, which we have given the directory name, and we are saving the checkpoints on the Google Colab. So here with the epoch is equal to 10, we are training the model, and this is the history where we are saving the model parameters, and this is the loss. We can see the loss is decreasing as the epochs are increasing. So once the model has been trained, so here we are generating a text. So this is for the RNN state is passed from time step to time step, and the model only accepts a fixed batch size once built. To run the model with a different batch size, we need to rebuild the model and restore the weights from the checkpoints. So this is the model summary after training. So this is our summary of the model. For the prediction, we have created one function here which will pass, and it will call the model, and it will predict the text. So here we are passing the model as a parameter, and the string start a string as a Sherlock to generate a text. So this is what the text has been generated from the model. Thank you.